Okay, this is the second video I'm doing on trig equations. This is part 2, and in this one we're going to look at negative domain and also situations where the equations are just a little bit more difficult than the ones we've been doing. So let's look at this one first of all, and you'll notice that the domain that we're looking at for answers here, negative 2 pi, comma 2 pi. So we're going to do this fairly normally as we do any other ones, and I'll show you something at the end that can help with negative answers to these trig equations. My general approach here is that I work out the answers from 0 to 2 pi as normal, and then in those answers I then look for negative equivalents to those angles and include those in my answers. That's just a general way that I go about them. So let's have a look at this equation here. First of all, it needs a bit of tidying up. So cos x will equal 1 over root 2. And we talked in class about having to rationalise those ones that have a cert on the bottom. So cos x would equal root 2 on 2. So that's basically our question now. Cos x equals root 2 on 2. And remember, our domain is from negative 2 pi to pi. So let's get underway with this one. Basic angle is going to be pi on 4. Basic angle equals pi on 4, and that's because we know that the angle in the first quadrant that has a cosine value of root 2 on 2 is pi on 4. Now we've got a positive term here, root 2 on 2, and we know that cosine is positive in first and fourth quadrants. Okay, so therefore x will equal first quadrant pi on 4, fourth quadrant 2 pi minus pi on 4, x equals pi on 4, comma 7 pi on 4. Right, now they're the answers if our domain was 0 to 2 pi. But our domain in this question is negative 2 pi to 2 pi. So let's see how we deal with that on the next slide. Okay, so our two solutions so far are pi on 4 and 7 pi on 4. Okay, they're our solutions from 0 to 2 pi. But what about the fact that our domain this time is negative 2 pi to 2 pi? Where are these negative solutions going to come from? Well, what I'm going to do is mark on my circle here the solutions we've got so far. So we've got 45 degrees, which is pi on 4. Okay, so we'll put that about there. And also got 7 pi on 4, which is around here. So there are our two answers so far. Let's write those down. So we've got pi on 4, might do a different colour. Got pi on 4 there, and 7 pi on 4 here. Now what are their negative equivalents? Remember, when we're looking at negative angles, we're going around in a clockwise direction as opposed to a counterclockwise direction. So we're going around this way. So that angle there of 7 pi on 4 is actually the same as the angle negative pi on 4. Okay, if you can see, we've gone around there, negative pi on 4. So that's the angle that's equivalent to 7 pi on 4. What's the angle equivalent to pi on 4? Well, if we go right round here, like so, in that clockwise direction, that angle there is negative 7 pi on 4. Because we've almost gone around a whole revolution in a clockwise direction, except for that last bit there, which is pi on 4. So our two solutions that match up with this and this that are negative angles are negative pi on 4 and negative 7 pi on 4. So our solution is going to be x equals pi on 4. In fact, we might put them in order. Go back a step. Okay, so from lowest to highest is negative 7 pi on 4, negative pi on 4, pi on 4, and 7 pi on 4. So that's a bit of a strategy there to deal with negative angles. There are other ways, and depends how well you know your unit circle, etc. But that's a method I just use. I just work it out for 0 to 2 pi and then look at negative equivalents. It gets a bit more complex than that though. We'll have a look at something different on the next example. Okay, this is a very important example, this one. 2 sine x plus 1 equals 0 from negative pi to pi. I'm going to show you a general strategy once again for doing this one. And you know, it works for me, and maybe if you're in Mr. Thomas's or Mr. Cooper's class you might see different methods, but we'll see how we go with this one. Okay, the big difference with this one, the previous example, is the domain this time is negative pi to pi, not negative 2 pi to 2 pi. But I'm going to treat it as if it was negative 2 pi to 2 pi, but at the end I'm just going to make sure my answers are in the correct domain, which is negative pi to pi. Alright, so first things first, let's fix this up. It's going to be sine x equals negative a half. Okay, so our basic angle here, remember we ignore the negative to get the basic angle, we're just looking for angles that have a sine value of a half, and we might be getting to know by now that that angle is pi on 6, 30 degrees. Alright, what quadrant are we in? Okay, sine is negative in third and fourth quadrants. Okay, now really important, I am going to work this out as if it was 0 to 2 pi. Okay, so I'm going to calculate answers as if domain is 0 to 2 pi. Now why do I do that? You'll see that when you do that you'll be able to see negative equivalents to your answers which might fall within the correct domain. So stick with me here because if you can use this method and use it successfully, you'll end up getting really accurate answers each time for negative domain questions, which can be quite tricky. Alright, so let's move over to the next page, and I'll just copy a little bit of this over to the next page so we can keep on moving. Okay, here's where we've got to so far. Okay, so we know that we've got a negative value for sine, so we're looking for third and fourth quadrant. So x in third quadrant will be pi plus the basic angle, and x in fourth quadrant will be 2 pi minus the basic angle. So that's going to be 7 pi on 6, and this one's going to be 11 pi on 6. Now notice how both of those are outside our domain, and our domain that we're dealing with is this one. Okay, and 7 pi on 6 and 11 pi on 6 are both outside that upper limit of our domain. But what about their negative equivalents? Let's have a look at that on the next slide. Here's the solutions we've got so far, and that's the domain we're looking at. What I'm going to do now is look at the negative equivalents to those two answers. Alright, so we've got 7 pi on 6, which if I include that on this unit circle here, it's going to be here, and 11 pi on 6, which is going to be here. Okay, and just remembering, we developed those because one of our answers was third quadrant, pi plus pi on 6, the other one was 2 pi minus pi on 6 there. So let's mark in those angles. This is 11 pi on 6, and this is 7 pi on 6. Both of the answers, remember, outside our domain. But what about their negative equivalents? And this is why we do all the solutions from 0 to 2 pi, so we can see what the negative equivalents are of those angles. Let's go back in our clockwise direction now, and we see that the negative equivalent here of 11 pi on 6 is negative pi on 6. The negative equivalent of 7 pi on 6 there, okay, and we're going back this way, from 2 pi round this way, is going to be negative 5 pi on 6. So if I got my answers from 0 to 2 pi, this would be the total list of answers. X equals, and in order, that'd be negative 5 pi on 6, okay, negative pi on 6, 7 pi on 6, 11 pi on 6. Now here's the beauty of this method. We now look at our domain, it's just between negative pi and pi. Okay, which one's falling within that domain? The first two. Negative 5 pi on 6, neg pi on 6. Let's write that better. Neg pi on 6. They are our answers. The other two fall out now because they are outside our domain. So the beauty of the method there, as I said, is to work out all the answers from neg 2 pi to 2 pi, and then look at your domain and say, well, I can't use all those answers. The only two that fall within that domain are these two here. So that's the final answer. Okay, next type of problem is a situation where you've got something else in this bracket here, other than just x, 2x, 3x, or theta, etc. You've actually got something tacked onto it, such as a plus pi on 3. It's a little bit of extra complexity here, but we'll work through it and see how we go. First of all, because we've got 2x there, I'm just going to readjust my domain here to 0 to 2 pi. And we've been doing that in class. You know, when we've got 2x, we double the domain, 3x, we triple the domain, etc. So remember that as well. But first things first, let's adjust this so that we've got it tidied up, ready to do. So it's going to be root 3 divided by 2, by dividing both sides by 2. Basic angle equals pi on 6, because from our knowledge of exact values, the angle that has a cosine value of root 3 on 2 is pi on 6. Alright, it's a positive root 3 on 2, so cosine is positive. Cosine positive in first and fourth quadrants. Okay, where do we go from here? Well, now we've got to look at setting up an equation here where we've got 2x plus pi on 3, used to be just 2x or 3x or 3 theta, whatever, equals first quadrant pi on 6, fourth quadrant 2 pi on 6. Sorry, 2 pi minus pi on 6. Now we need to be a little bit careful here because what's going to happen at the end? Well, at the end you'll notice that we've got a plus pi on 3 here. So one of our steps in a moment will be to subtract pi on 3. So a handy thing to do here is to go one extra solution, because that next solution, even though it's outside 2 pi now, in a moment once I subtract pi on 3 from it, and this will become clear when I do it, we'll bring it back within the domain. So for these ones here where you've got, whoops, we've got a plus pi on 3, okay, or plus pi on 6 plus something, handy, in fact necessary, to go to an extra solution. So I'm going to go one more, okay, and the next solution will be 2 pi, first revolution round, plus pi on 6. Okay, so we'll copy this over to the next slide, and go to the next step. Okay, this is where we've got to. Alright, so 2x plus pi on 3 equals pi on 6, 11 pi on 6, and this one here will be 13 pi on 6. Rightio. Now, what we've got to do is subtract from each of those. To get 2x by itself, we need to subtract from each of those pi on 3. So, got to look out here for our fraction skills. Notice how for each one I'm subtracting pi on 3 to get 2x by itself. Alrighty, I'll do the first one. Here we've got pi on 6. It's going to be minus 2 pi on 6. So I'm just converting all these pi on 3 terms to 2 pi on 6, so it makes it easier to subtract. You can do this in your head if you wish, just doing it the longer way for those that need a bit of help with their fractions. So 2x equals, it's going to be neg pi on 6, 9 pi on 6, 11 pi on 6, and copy those over to the next slide. Okay, so we've got this far, 2x equals, then we divide through by 2, and we get this. Now, let's remember back to our original domain. I'll go back a couple of slides. Our original domain was 0 to pi. Now, if I look at the three solutions I've arrived at, that one has gone outside that domain, because when we've subtracted the pi on 3, this guy here has gone below 0, so it's gone out of the picture. But notice how this guy here, when we subtracted pi on 3, has come into the picture. It's come into that 0 to pi domain, okay, because of that subtraction. So our two answers, and we've got to cancel one of them down here, are 3 pi on 4 and 11 pi on 12. So just to recap there, in this situation, I doubled the domain because of the 2x factor. Okay, I've also included an extra solution because when I subtract pi on 3, it may bring this solution, and it did, back into the correct domain, which is 0 to pi. It took this one outside the correct domain. So when we work through, we end up getting those two answers. Okay, so I'm going to attach in a moment on Schoolbox a sheet of harder trig equations, and also post up this video in a moment as well. That's all for now.